greetings, everyone. I'm Salvador Cordova. Welcome to the Evidence Reasons Academy. This is a sister channel to the Evidence Reasons for the Christian Faith channel. And this channel is really dedicated to exploring academic issues, partly because there is a small segment of the viewership on my main channel that are graduate students, they're professors in science. There are graduate students in science. We have a scientist who works at a particle accelerator that is a frequent guest. And actually, Grayson, I know we have different faith views. It's customary for me to pray. I hope you won't be offended if I open the show with prayer. Would that be okay?
Yeah, no skin off my bones, whatever's clever.
All right. Lord Jesus, we lift up Mr. Jetty 89 out there in Ukraine. Please keep him safe. We lift up friends and family who are in dangerous places around the world. Many of those are in the side chat. And just thanks that Grayson could come here, and please grant him health. Help this discussion to be honoring to you. And please be with all the graduate students and college students that are just struggling, and also the researchers that are a part of this channel. Glory and honor to you, Lord Jesus. It's in your name we pray. Amen. So, Grayson, I'm really glad you could be here. We had some, how all this started is Factitian, I can't pronounce his name, Kaz, who was our moderator at Modern Day Debate, for our Big Bang debate this past Tuesday, February 28, 2023. He said, man, I'd really like to host the debate. Unlimited time, just like, man, he really does want to hear us talk. and so we tried to contact him, and at the last minute, he said, I can't, do it today, some other time. And I already had scheduled this. So we're kind of, I said, well, we have people that are waiting for this debate. And so why don't we at least talk today, and we can also figure out what we might do with Kaz, because he seemed like he really wanted to have us on his channel. And so we're going to do a little bit of that. I'd like to suggest a format. Have you ever heard the term Brandolini's Law?
I saw you talking about it, so I looked it up after the fact, and I generally agree with it. That's basically that the amount of time it takes to address BS in an argument is often more time than it took to spew the BS in the first place. So that's why debates oftentimes don't have enough. The time constraints don't really work for you to be able to adequately address all of your opponent's points.
Right. And then there are times in a debate, it's like I might be unsure of a claim, even on my side. And it's like, can we just pause and just look?
Yeah.
And so I was about to suggest this is going to be all right. So the other thing is, debates are often organized for the audience, not for the people to actually have a real discussion. And preparing for debates like that are not fun, because in a regular discussion, like let's say we were just students at school, and we're trying to work out a paper to present to the class. And the two students might have some disagreement. You can resolve it with a conversation. But if the two of you are forced to be up there on stage and just, your goal is to try to just make as much theater and put the other guy down, the way it is conducted is different. So for an unlimited time debate, I said, for the benefit of everyone, for you, for me, for the moderator, for the audience, we're just going to say it's not going to be about theater. You're going to be bored to death, but I'd be interested in just fact checking. And so that tends to be kind of a bottom up construction of how to do, and it's not, at that point, it's not really a debate. It's just really like just a lot of fact checking, and then we say, okay, these are the facts that we have in hand. We can disagree about its meaning, but at least we're going to start with the basis that we have a common basis of what we agree is factual. And if we can't agree even on what's factual, we can at least say, okay, so-and-so reported this. We can disagree with the report, but at least we are making accurate citations of what someone said. And
Well, I can completely agree with that framework, and I agree with your points. Although I do think that we can make it still interesting and entertaining for people to watch. I don't think it has to be a total snooze fest. That if we have a focus on figuring out, what are the facts, leaving out biases and interpretations, and just looking at, where does the evidence lead. I still think that can be definitely interesting. So that's the only disagreement I have so far.
Okay, and we can work with that. Rebecca, who is my tag team partner, she's complained that I'm really long-winded because all right, so what you saw on Tuesday does not represent normally the way I communicate on my channel. The way I communicate on my channel, I'll get a peer-reviewed paper and I'll just read it and I'll comment. And I've had 4-hour monologues because some of this stuff is just tedious.
Yeah.
I'll go through my textbooks and I'll just read and I'll say, I don't understand this. Let me look it up. All right. So
Okay, well, that can get a little bit dry, I will say. I don't necessarily want to just be, reading from papers the whole time. Maybe like relevant snippets from the papers. Yeah, that's like a valid way to source information.
So we'll try to balance this out, because after all, we're trying to, this is on a volunteer basis, and we're not here to just bore each other to death. Now, professionally, I've had to do that because people are counting on me. I have co-authors. We're trying to submit to peer-reviewed journals, and sometimes I just put it out there and people like Dr. Dan will come and say, hey, Sal, don't use that. That's not good. And so I've written to Dr. Dan. I said, he and I are on totally opposite sides. But I said, if there's anything that I say, especially if it upsets you, if I've misrepresented your field, you can write me. You have an open mic on my channel. And I said, one, I'm glad to actually, it kind of like, it puts him in a funny position because it's easier if I say something wrong and he can just pounce on it on his channel. But because I give him an open invitation, he comes here and he corrects me, and then I'm not forever embarrassed because of something I said. I'll say, hey, thanks. What he could do is wait till it gets into a peer-reviewed publication, then he can discredit the co-authors in the journal. So, and he hasn't done that, but I usually try to say, okay, someone who's really qualified can come on this channel. Even like yesterday, I had someone who is a young Earth creationist, but he's also an excellent secular scientist. He has worked for NASA in the field of general relativity. He's published in the Physical Review Letters. Dr. Philip Dennis, member of the American Physical Society. You don't attain that unless your peers, the top physicists in the country would be willing to, recognize his qualifications. He said he goes to physics conferences and they know him, and he gets along well with them. He has his own solutions to the distant starlight problem, but he is he's a very capable individual, and he was here teaching me, helping me relearn relativity. It's been like 12 years since I've studied relativity.
Well, that's cool. You said that this was your latest video on your channel. I'll check that out.
Yeah, you'll see it. It's Dr. Phil helps Sal work through relativity. Now, unfortunately, we didn't start the video. It kind of looked jumpy because it wasn't there. But this is what the academic channel is organized for. Now, it's not like a college course where you start from step one. You'll just see me actually make videos on active problems. And sometimes there are people who watch this that will actually help me through. And that's actually important because like yesterday, there are a lot of software guys And there was someone who's studying quantum computing named Schnoil, and he's a computer scientist. And I couldn't get something as simple as getting my equations to render on LaTeX. I could do it in Microsoft Word, and I'm working on a publication on the Lorentz transformation and connecting it to electromagnetic theory. It's supposed to be a educational paper, but it's foundational to some of the later views that I'm having. So if I put the word nerd dumpster fire, it's like that's going to be like just a totally boring. I'm just warning people. But some people actually, the computer scientist watched, and he watched. I couldn't believe he watched through it all. And he said, Sal, I can help you with that. I can help you fix that. And I said, thank you. So there'll be some presentations that are going to be much more polished. So what'll happen is as I study general relativity, I'll have a dumpster fire session, and then I'll have a summary session where I describe what I learned.
Mm.
And I might title it appropriately. I've also had kind of like, I've had some shows with Cindy Lincoln on molecular biology that would probably totally, it might not be something for you. It'd be for people like her. And then I'd have a graduate
I don't
student.
know who that is, but just FYI, I mean, I was a biochemistry major, so I definitely enjoy that topic.
Oh, fabulous. Fabulous. I'm very pleased to hear that. So she does not have a background in that. And I was trying to teach her the central dogma of molecular biology.
Oh, okay.
And okay, Cindy Lincoln was Kent Hovind's third wife, ex-wife.
Oh, okay. I know who you're talking about now.
You could probably guess whose side I'm taking, given that Cindy Lincoln I've taken her kind of under my wing to teach her stuff.
Yeah, that's nice. I've debated Kent myself a couple times, so that's.
I'd like to debate him and say, my debate topic is: it safe for kids to go to your dinosaur adventureland? I know that's kind of low, but I just despise the
No,
guy.
it is not. That's the short of it. No, I would not. I would not recommend kids go there.
Yeah, that's where I was. I'd say absolutely not.
Yeah.
And so Cindy's my friend. I also have a pretty low opinion of Kent supporters on YouTube. I banned them from my channel, like Standing in Poop, and
Wow.
can't stand the guy. He called me a fraud.
Whoa.
And I get pretty insulted when people associate me with Kent. I mean,
Yeah.
stand
Well,
the
I'll
guy.
be sure not to do that then. I'm glad that you've kind of clarified, and I'm glad that we could also kind of start off this whole discussion with like basically a series of agreements. I don't think we've really disagreed on anything that's substantive yet. Granted, this is still kind of like setting the foundations for our next debate, but I was going to ask, did you want to save everything for that debate, or did you want to kind of say, these are the, like, did you want to kind of make a roadmap for what you wanted to talk about during the debate, or?
Why don't we just kind of go through things, and you'll say, we don't like to do this format. Let's do it a different way. Look, okay, I'll tell you my interest in this. There were some things said in the debate I would just like to fact check for both sides. It's whichever way we'd like to do it. So I did throw out some papers there. It's fair game to say I don't agree with those papers. That's fair game. But what has to be fact checked is, did I represent what the author said?
Mm-hmm.
And so, so I'm not going to necessarily say I'm not going to argue whether a paper is right or wrong, because some of this is so far outside of my expertise. And publicly, Rebecca, a mathematical physicist, PhD. I mean, that's kind of the elite. And it was really funny. I talked to a mathematical physicist yesterday. That was Phil Dennis. She talked to Blitz, PhD, who's a Big Bang advocate. He watched the debate, and then, which is like an hour and a half, and then spent 2 hours with Rebecca. Wow. I mean, that's a long time to invest. That he would think she was worthy of his time.
And what is this on a video, or?
We're trying. Okay, it was on TikTok, and TikTok doesn't record certain live streams. I don't know how all that works. someone did record it, and it's Danny the philosopher, and we're trying to beg him for a copy of it.
Okay. Yeah, because I'd be interested in watching that as well.
Yeah. So, oh, if you don't mind, factitional just wrote back, and um, let me read this, and if it's not sensitive, I'll communicate it to you. He said if you still want to do unlimited time debate, he suggested a time, and for next Sunday, he said it's okay with him.
Okay.
We can talk about that today. So this is why it was good that we meet.
Yeah.
Because it may not, he said anytime after, Monday, and it's like, well, we'll have to see about that. Why don't we just kind of have a discussion here and see if we can move forward. So where I was headed with that is, I think, these Kent Hovind debates, I said everyone kind of, okay, for someone like me, I just cringe. I said everyone has just wasted their time. So I would want our discussion to feel like people have come away learning something.
Yeah.
Even if they disagree, we have at least clarified what is factual and what was really just made up on the fly.
Well, I think I learned things from all my debates. I've even learned things from my Kent Hovind debates before. Like, he'll ask a question that maybe I hadn't asked myself, and then I'll go research it afterwards, and I will end up learning new things. So that was the case for our debate. I ended up learning a lot more about interstellar and intergalactic plasmas afterwards, by like reading up on it after our debate. So I end up learning things from all my debates, really. So sometimes, even if they don't immediately feel productive, there can be some kind of, silver lining to be gleaned afterwards for everyone involved.
Yes, agreed. Let's try to maximize that, and then also not try to bore each other.
That'd be a good tightrope to walk.
Yeah. Okay. So I think it's worthy to say our goal is to try to be, keep we have to mutually agree what's interesting to us. I mean, otherwise there's no point in discussion. So with that, okay. So in the debate, you said something about, you had some comments about plasma, and then Rebecca came back and said that's nonsense. Now we could either play it back, or you could tell us what you learned about the interstellar medium.
I'm not sure what Rebecca was referring to as being nonsense. If we want to play it back, we can, but I'm pretty sure what I said was that I didn't see how it'd be possible if you take a plasma and you make it less and less and less dense. I was thinking, of course, that's going to make it cool down. And when it cools down, it's no longer a plasma. But what I think I misspoke about that. And what I should have said was, it's not necessarily the density that makes it a plasma, it's the energy. So you can have a very, very low density plasma as long as the individual particles that are making it up are very high energy. So if the particles are still too high energy to, even if they collide, they're not going to combine to form atoms. They're just going to bounce off each other and still be a plasma. So I've learned that actually a large proportion of the cosmic web, which is the largest scale structure of the universe, is composed of these very diffuse low density plasmas. So I think I read something like half of all the matter in the universe is in the state of these low density plasmas, which was a really cool fact to learn. And then also the properties of these intergalactic plasmas vary depending on how close they are to the filaments in the cosmic web. So all the galaxies are kind of structured in these filaments, and then there's a big vacuous empty voids between them. So you have very little of this plasma, and then it gets more higher densities closer to the galaxy filaments, and higher temperature for the individual molecules or atom nuclei of the plasma. So I learned a lot that was really interesting to think about. So all that came out of the debate because afterwards I was like, I tried to Google low density plasmas because I don't think in the debate I ever claimed that it was impossible. I think my claim, which was accurate at the time, was like, I don't know how this would work. So I was sort of, I wouldn't say I was making a positive claim. I was just stating that I didn't know about low density plasmas. So if during the debate, I know that there's not enough time to address every point, but I would have been open to hearing about like basically the explanation that each individual particle would still be high energy. It would still be in a plasma state. And so the temperature of each particle in the plasma is still too high for it to cool off, even at low densities. Then that would make sense to me. I think in the debate I said something about it doesn't make sense to me, or I don't see how that could be. So, yeah, I ended up learning a lot about that afterwards, and it was I don't know. I think they're pretty cool, these interstellar plasmas.
Well, I'm really grateful because that's why Rebecca came out and said that's nonsense. Okay, so again, this is a short form debate, and she just had, I'm actually kind of glad she stepped forward and said that because, okay, first off, the idea of temperature is really hard when it gets sparse. I know that from statistical mechanics and thermodynamics. They said, well, when you have a high density state, uh, the concept of temperature is kind of like normal. When you get to very sparse situations, it starts the idea of temperature and a lot of the thermodynamics, because a lot of thermodynamics and statistical mechanics is driven by the law, kind of by way of analogy, law of large numbers.
Yeah.
You won't really see that in paper, but it's the idea that, if you have two atoms in a container, it's like kind of hard to define temperature, and
Yeah.
you want to have a lot of particles. So this one,
But you could still talk about the average temperature for a group of the like plasma nuclei. Like you could still talk about just, the energy of each of the particles and then adding them all up and averaging them, that would give you a temperature.
right, it's conventional now that when you get into these situations, first off, you get some really strange things like directionally dependent temperature, which was like, when I first heard that when I was studying plasma physics, that was like, oh, what is that? Never, that's so. And then they said at that point, temperature is usually expressed as in electron volts. So our first fact check. Temperature expressed. Uh,
But I will just
all right.
also
So,
point out that the existence of low density plasmas, I don't really think is supportive evidence against the Big Bang, or I don't really see how it's relevant in explaining any of because I mean astronomers and astrophysicists are aware of intergalactic interstellar
right.
plasma, so this
Okay.
is something that's like
Well,
known and factored into our observations.
okay. I'll tell you why it's significant, because if there were no plasmas, because I specifically cited um, free electron plasmas in space. And so when an electromagnetic signal is passing through a free electron plasma in space, uh, in the corona, we're saying the argument that you're criticizing is whether we could extrapolate it to sparse plasmas.
Yeah.
Now, what I had done was I actually found out that space probes have gone out to way beyond the solar system, and now they're touching interstellar plasmas, and they're extremely high temperature. So I'm just gonna. This is. I hope you won't mind, but I feel like an obligation to my viewers that I actually will. I want to cite the sources real time. So
Okay.
okay. Um, high temperature plasmas. Hang on. Uh, okay, so here it is. 89,000 degree Fahrenheit wall of plasma surrounds our solar system. 89,000 degree right here.
Yep.
An 89,000 degree Fahrenheit wall of plasma surround our solar system. Okay, so this is really kind of strange because it's so sparse. It may be at 89,000 degrees, but it doesn't mean that if you fly through it, you'll necessarily burn up. That's probably why the space probe that's detecting this hasn't melted. Okay.
Yeah. It's just
All
that
right.
the average temperature of the plasma particles themselves is 89,000 degrees.
Okay.
They're
So
so dispersed that the average temperature of the area is not that high.
yeah. So what'll happen is if it hits the spacecraft can absorb it. It can lower. It's just like when you take something really hot and drop it in water, it'll cool.
Yeah.
It'll cool everything off, and then it can radiate it as electromagnetic radiation. So this is actually a really tough problem that I couldn't. Okay, so a lot of stuff with temperature and energy is you can you can convert the kinetic energy of all these particles, um, and somehow it can be radiated as an electromagnetic wave. I think that's converting the phonons into photons, and that's not my specialty. If I totally mess that up, guys, correct me. But that's how, like an object in space, like say a spaceship, if it's trying to radiate heat, it can cool itself off by converting it to black body radiation. You can get a black body process to cool off. Now, why do plasmas not seem to have that black body radiation to cool it off? I don't know. I mean, 89,000 degrees Fahrenheit is really high. Okay, so
Yeah, I mean, plasmas do have emission spectra.
yeah, okay, so I'm just going to we don't need to go down that rabbit trail, but so a lot of my claim is there's interstellar plasma, and what
Yep.
was the figure you gave? About half of the
Half of
cosmic
the
web.
matter in the universe, like not dark matter or whatever, but just like normal baryonic matter, is in the form of these like the interstellar plasmas
I
or
didn't know that.
intergalactic plasmas.
Okay, so this discussion taught me something, and we have. All right, so
Hey, be free to fact check that, by the way. But that's what I read up whenever I was reading up on this after our debate. That's what the
oh,
figure I came
okay.
up with.
By the way, feel free to if you want to Google stuff and share your screen, you're welcome to.
Okay.
Half
The main thing
baryonic.
I was going to bring up with these plasmas was that, like, one, like astrophysicists are aware of the existence of these plasmas. So, like, I would think that it's not like some big thing that they're missing that explains all this other variables. Like, they're aware of these interstellar plasmas. And then two is that, as I said before, in the cosmic web, there are voids where there's a lot less of this interstellar plasma, and there's points where there's a lot more of it in terms of densities. So if the redshift effects we were seeing were actually due to these plasmas, then we would not expect the redshift effects to be uniform. If we pointed our telescopes in the direction of the voids, we would expect to see less redshift than when we point them in directions with a lot of the plasma, which we don't see.
Well, actually, it's been offered. I just wanted to say, people on my side of the issue, I'm not a plasma cosmology.
Okay.
I'm saying plasma redshift. There's stuff in plasma cosmology in the plasma universe. Unfortunately, we come by the same moniker.
Yeah, interesting. I'm not familiar of what the difference is, but I mean, we don't have to get into that if you don't want.
Okay. So first off, the fact check here is score one for your research. This is the Harvard Smithsonian. According to theoretical calculations, the intergalactic medium, the IGM, contains roughly half of the atoms in the universe, with the other half being in galaxies, including stars, planets, and interstellar gas. So that is huge. That is a huge amount. So how this relates to, okay, I'm not saying this is right or wrong. I'm just going to articulate the viewpoint. So that disagreement among when they're trying to do the Hubble measurements and come up for what is the Hubble constant? And if you want to share your screen at any time, just say so. And I'll usually see it here, and I'll throw it up soon. Is that is due to the fact of what you just pointed out. The density changes. So you can actually look at different objects. You're going to come up with a different Hubble constant. So I think we've beaten this horse dead enough that, that was what I wanted to just verify. This was very informative. So that leads to something else. There was an argument toward the end about the Hubble law. And Leo said, the Hubble law is the measure of the expansion rate. And Rebecca said, no, it's not. And we could just go say, yes, it is. No, it's not. And it could also be the choice of words. And so it's the English language can give us a lot of problems. That's why I like math. I mean, you can characterize the same thing different ways. For example, if you have a baseball at its zenith, if you throw it up in the air, its velocity is 0, but its acceleration is still 9.81 meters per second squared. And you could talk to philosophers or whatever, and they'll say, no, it's not moving because the velocity is 0. And someone will say, well, yes, it's moving because it's accelerating. I'm just like, it's semantic games.
Okay.
So my point is the Hubble relation, depending on how you define words, you could say the Hubble relation it's not about expansion, or you could say it is. Probably the way to settle this is just the simple math, and not to settle it, but say, okay, let's just talk the math. And so Rebecca here was very good at finding Hubble's own writings. He said, now let us adopt, this is from Hubble's book, The Observational Approach to Cosmology. So I'm just trying to communicate where she got her claim. It's from Hubble's writings. Now let us adopt the first alternative and assume that the redshifts are not velocity shift, that the universe is not rapidly expanding. Okay. In this case, the redshifts are strictly proportional to the distances over the entire range of the data. Within the very small uncertainties of measures, the law of redshifts is strictly linear as far out into space as spectra have been recorded. The law is expressed as follows. And so that's where she got it. And so if so what is happening is the Hubble law.
Can you scroll down a little bit?
Oh, sure.
Where he talks about the implications of this result.
Yeah, sure.
So he says the implications of this result are important if redshifts are not velocity shifts, which we don't say nowadays. We talk about apparent velocity, not true velocity of galaxies. Light loses energy strictly in proportion to distance, which is just the tired light hypothesis that's been debunked, right? So it's not
Well, you said it's been debunked. I don't use the word tired light, but I interrupted you. Please go ahead. I apologize. Go ahead, Grayson.
No, I don't need to read the rest of this. I mean, he's basically saying that if we assume that it's not from expansion, we assume a non-expanding universe because Hubble did not believe in an expanding universe. He's saying that the implications for the correlation between redshift and distance would imply in Hubble's model that he's proposing that light loses energy in proportion to the distance it travels through space, which I'll say again has been debunked. I mean, we don't have evidence for this.
Okay, I respect your viewpoint, and I apologize for interrupting you mid-sentence. I'm going to try not to do that. I apologize.
It's all good.
You said it's been debunked. I should let you say that, and I'll say I don't think so. And
you are far from the worst perpetrator of interruption, Sal. You really don't have anything to be sorry about.
Okay, so however we characterize it, okay, that's it. The man himself had said, okay, if you assume this, the Hubble law means expanding space. But if you assume non-expanding space, it means this. So I think one way to phrase this, the Hubble relation, the distance redshift relation, does not necessarily mean space is expanding.
Okay. I mean,
it does not necessarily. It can be adopted in an expanding space model and say, this is the expansion rate if you believe in expanding universe.
Yeah.
If you do not believe in an expanding universe, you can still accept the Hubble law, but it means something else, like he described. And this was Hubble's words in himself. I got to credit Rebecca for finding this. I could not believe that she would be digging up Hubble's book and reading it. I mean, okay.
Yeah, that's kudos to her as she does her reading, but I mean, I knew that Hubble was a static state. He didn't believe in the expansion of space. I mean, that's kind of well known, but um, I'll just say that. Oh crap! I had something that I was gonna. When a point just leaves your brain, you know. Um, but basically, oh yeah, yeah. I will agree with you that it's not like that the observation of redshift and distance, the correlation, could be explained by another model. Like hypothetically, we would have to see what models could explain it. So the only model that I've heard besides the expansion of space, which like our observations are in line with a model of expanding space, but in order for like so I do think that it's supporting evidence for an expansion space model, but it's not like necessitating expansion space model. So if we look at, what other models could explain this, like tired light, like Hubble proposes, then we look into like what that would imply if tired light was a real thing, or if plasma cosmology was a real thing, and then we see that it's not supported by the preponderance of the evidence. There's no blurring effects that we would observe in either of those two cases. That the time dilation cannot be explained by the tired light. I mean, there are a number of things that tired light and plasma cosmology cannot explain about our observations that are explained by expanding space models.
Right. So to that effect, that's why I threw the papers out about the absence of time dilation. Now, it's way above my expertise to decide between David Crawford and Nobel Prize winner Saul Perlmutter, who claims that we have found evidence of time dilation. So I'm just going to say, in the debate, I said it may have failed this because I said it is controversial. I did try to qualify it, did not try to represent it as the only viewpoint. And I
You're
did
talking about for
mention,
quasars, right?
huh?
With the time dilation, you were talking about like for quasars.
So there are gamma ray bursts, quasars, and supernova.
Uh-huh.
Each of those has been contested by your side, and my side have said no time dilation. This is a scientific. At this point, I'd say this is a scientific discussion that needs to be resolved by the community because it is a significant question. It's not something that I think me at my level is going to rule on. I said I have, although I would say as to be a responsible person, I said, I have to put this on the table. People will say these guys are cranks or whatever, but David Crawford is a professor of astronomy. So it's not like this came from someone that had no expertise. So I'm just saying.
Is he actually talking about supernovas though? Because my understanding was that there is a question of time dilation with quasars, because I mean, obviously quasars are supermassive black holes that have time dilating effects from all their gravity, but I was not aware. I mean, it was my understanding that with supernovas, the time dilation is like a consensus fact among astrophysicists.
Okay, consensus is not fact, by the way.
That's why I used this consensus as a modifier for
right.
fact.
So I'm just saying, look, I put it on the table, and to say, at least in my mind, it's not resolved. It may be resolved in your mind. It's not in mine. The other thing is, and I'm just saying this sincerely, I would like to have a conversation with Dr. Crawford and then other astronomers. So this is a technical thing. What he did is he looked at the Sloan Digital Sky Survey.
Mm-hmm.
I mean, I think it's going to be an interesting conversation because he's appealing to publicly available data.
Yeah, that's good data.
Which is like, okay, how can two parties look at the same publicly available data and one party says there's time dilation and the other does not? To me, that's a very interesting. This is a very interesting. I want to know why.
Okay.
I want to know why.
Sure.
I'm just putting it out there. So when you said tired light does not explain time dilation, it would be an automatic fail. I will say in 2005, when I saw that, I said the other side, the Big Bang advocates, definitely have a point. I recognized that immediately. And I just said, okay, I'm going to have to assume, and when I gave my talks on creationism, I said, this is really good data because I knew there could be people there that are going to go on to cosmology school, physics students. I said, I got it. I got a level with you. They have a very good case here. Hugh Ross has a really good case here. And then I met John Gideon Hartnett, who is he invited me to be his PhD student down there in Australia. He's a young Earth creationist. He works for the European Space Agency, builds sapphire-controlled oscillator clocks, which are the most stable in the universe. And so the European Space Agency was interested. 200 peer-reviewed papers, like $10 million in grants. He's an established secular scientist, but also a young Earth creationist. He was the one that alerted me to Crawford's work. And I'm like, whoa. So I'm just telling the history here. So if we could just say, we'll have our opinions, but I would like to see the issue conclusively explored, more space
Yeah.
probes or whatever. That's how I feel.
So I would need to be more familiar with Crawford's methodology to be able to weigh in. Like, I haven't gone through Crawford's work,
Okay.
so I definitely can't offer any kind of opinion on
Likewise.
something that I'm not that familiar with. So I'll look at it. I'll look into it after this, though. So maybe before our next debate, whatever, I'll be able to weigh in on Crawford's paper a bit more. But I will say, just the observation that light loses energy with proportional to distance is not corroborated by any kind of observational evidence. I mean, even if we leave out time dilation, just there are other aspects of tired light or of plasma cosmology that are not within, that's not what we observe.
Well, okay. So what I wanted to say is we can revisit that question in that because of the 1974 paper on the Pioneer 6. They had eliminated relative motion and also gravitational time dilation as that signal was sent from Pioneer 6. And they said there was a residual that had to be caused by the plasma. And we don't know. Okay, so I'm just pointing this out. The best argument that I've heard against this is the lack of blurring. But I said, look, if half especially now that you gave me that data point, if half of the atoms in the universe are in that interstellar medium, there's a lot of plasma out there. And if we just extrapolate what we saw in the high density case, which was the solar corona density, okay, granted that extrapolation may not, so notwithstanding that, if it is to the extent it is valid, then that redshift relation of loss of energy will hold. We have direct experimental evidence of that right now. We at least have enough to say there's a possibility. Now, I've been monitoring papers to see redshift in the laboratory under various conditions, and I'm finding a few experimental things in the laboratory where redshifts are induced in plasmas. They're not many. And just for the audience's sake, I actually have been applying for PhD positions to study photonics, and this would be a high priority experiment. One professor that does work on lasers who interviewed me, he said one of the problems we have in laser technology is the laser beam starts to either be blue or red shifted inside. He said we get undesirable effects. And we have to, as we're trying to build some of these, we want to kind of eliminate that. Now, these were, as far as I know, solid state lasers. But so people are aware of the effect. And there was one experiment where laser light in a plasma was redshifted. So we do know there is loss of energy. We cannot, at this point in my view, you cannot deny there's going to be loss of energy. You cannot deny we may not have absolutely proven it for the interstellar medium, but to say that it cannot be redshifted by a plasma, I think that is way premature, and I think it's falsified. Go ahead.
Okay, yeah. So I have not made the claim that plasmas would not redshift light, right? I mean, I just want to be upfront.
Okay.
Apologies. I'll acknowledge that plasmas do have the ability to redshift light, but my claim there is that always comes with blurring, because the way, the mechanism for how plasmas are redshifting light would be from like scattering like effects. So that's going to result in blurring. All of the laboratory methods that you're talking about would have also resulted in blurring, which we don't see. And then, yeah, I still am skeptical of our ability to extrapolate the redshift from like the coronas, like close to stars, like at a much higher density of plasma than for much lower densities of plasmas. It seems like the amount of redshift that we would get, I mean, you know, maybe you can find the math or do the math, but it seems like if we were to calculate using the density, like, if we were to look at the densities of the average amount of interstellar gas, intergalactic medium, plasma rather, not gas, and calculate the amount of redshift that it would cause at those low densities, I don't think that it would be able to equal the amount of density that we see. But I haven't done the math on that. So if we want to,
Okay.
figure out
I,
how we could do that math, that might be worthy to look down. But
I,
again,
I have an archive paper on that.
okay.
Now,
And if you can get your PhD student and you can do your research and you can prove tired light, I mean, hey, your legacy would be secured, Sal.
okay,
It's
so
like
I'm
with
not okay. I got to say
like,
this. I
yeah,
would not have been interested in this unless usually if you feel like you're the first one to discover it, you're probably wrong.
yeah,
Okay, so my interest in this was because people had been who are way above my pay grade. They're actually expert photonics guys at Princeton. Okay, quietly, and so they'll say, "Well, they're not cosmologists." I'm just like, "Wait, whoa, 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 whoa!" Their specialty is in lasers and photonics
yeah.
and plasmas and sparse gases. I'm like, they have the skill, and I happen to have a paper to that end. So let me just throw this out there. The problem is we don't. There are two problems, and one of them Andrew Cumming brought out. How do you not get all the shifts uniform because matter interacts differently on wavelengths? The
Yep.
paper that I cited by Trinchera on this Pioneer 6 anomaly, his mechanism is frequency. You'll get different frequency shifts. You'll get different red shifting depending on the frequency. Okay, so there's one camp that says frequency will be changed. There's probably another camp that say it won't. And that's kind of an outstanding question. So, first thing, let me address Andrew Cummings. I looked at this. Actually, when we calculate redshifts for high redshift objects, we actually we don't actually sample the entire spectrum. There is something called the redshift desert. The reason for this is because different frequencies interact differently with matter. We can only build detectors that can sample small pass bands, a range of frequencies. And no one really knows, to the best of my knowledge, people have attempted to do this to see if the entire shift applies across the entire spectrum. I don't
Would
think.
that matter though? I mean, if you're wanting to say whether or not this is discrete or continuous, even if you were sampling over like a narrow range, you would still be able to tell if it was discrete or continuous within that narrow range. And like, if this was due to interactions with plasma or other forms of matter, we know it should be discrete, not continuous, among any range that you look at.
Well, what I meant to say is what would be bad is if we look at an object that we've decided this object transmits on all frequencies, and we see that parts of it are way more redshifted than the other parts.
Oh, okay.
That would be problematic. That would favor a plasma cosmology, and definitely would not be. That'd be kind of bad. There's only one paper that I saw that tried to explore this question. Do we see it? Do we really, 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 really see it across all frequency bands
Okay.
for red shifts, like say above 6 or 3? I mean, for low red shifts, you will see the whole thing move. So I'm just saying that's an open question. Now, and so this whole thing about the Trinchera's paper, he's actually coming forward and saying, I'm expecting that you will see uneven red shifts when you look across the spectrum. And I've actually looked at some of the data, and Varshni was looking at the samples of the very spectrum. He said, which you may hear in the popular press that we determined the redshift here, it's not a done deal. And I looked at papers that said redshift misidentification. And it's really funny. You have some guy say, this is a redshift of 17, and another says a redshift of 4. And so I'm just like, oh, so there really is ambiguity here.
Well, you're talking about like the Z values, right?
Yeah. So
Yeah.
it depends on the situation. Objects close to us, they do what they call spectroscopic.
Yeah. Well, I was
Look
just
at
gonna say those Z values are like given to like celestial objects, not certain frequencies of those objects. Like every frequency that is emitted by the celestial objects is given the same Z value for redshift.
So let me just say this open question, how, because I looked at it, misidentification of redshifts, and they're debating, okay, is this redshift 17 or redshift 4?
Sure.
And there's nothing in between. And it caught my curiosity, and I said, how did they do that? So there's the basic spectroscopic where it's like a prism. You can actually see the whole spectrum. And then they have what they call photometric, which is not as direct. And I don't know the methods for that, but it's not, just suffice to say, this is an open question, and we just have to leave it at that. So, but that being said, if you have that much plasma and you're redshifting, the problem then is to figure out why it's not blurring. Because I'm just saying the logical thing is we have plasmas, we've confirmed if we confirm in the sparse state, it loses energy. Then we have to figure out, our question then is to resolve why it's not blurring. So to that effect, I found this paper.
Well, hold on. Before you go into the paper,
Okay.
I just want to say, I don't know if I would agree that it's an open question, first of all.
Okay.
And then again, I would not acknowledge evidence for like a tired light, like light losing energy as it goes distances. Again, maybe you might prove that with lasers in the lab or something one day, but at this point, I don't see the evidence for tired light. So I just wanted to make those points before we go into the paper.
Yeah, that's fine. Okay, so what I'm saying is, you may not feel that way. I feel it's an interesting question enough that I wanted to pursue a PhD in photonics, because
I think that's cool though.
If not, okay, not for my, okay, a lot of people don't really get why I do some of what I do. I've said I've done this just because I'm really curious to find out what the truth is. I'm not out for, trying to win a debate. That's fun, but I was just genuinely curious. And oh my goodness. Okay, so Mr. Jetty works at a particle accelerator. He's like the smartest guy I know. So this is the paper that I looked at. It is not accepted in peer review, but M.N. Schneider is a professor at Princeton. Department of Mechanical and Aerospace Engineering, Princeton University, and VV-CMAC is a virtual laser application design. And he derives the Hubble law all the way here. I'm not saying is right, but in the Trinchera paper that I did with the Pioneer 6 anomaly, Trinchera gives his okay, so you see it here, the Hubble constant. So he can derive the Hubble constant. So they have their theories of how the Hubble constant is derivable. So this would not be velocity based. This is, again, a reframing of the Hubble law, kind of in the spirit of what Hubble himself had suggested. And so what they are saying is, in single photon interactions, you will, this all began it actually was a simple question. Why is the sky blue? Different perspectives on why the sky is blue. Theory of single photon scattering on bound and free electrons. And they're criticizing both the Rayleigh and Thomson scattering mechanisms. And to me, this was actually really interesting that they were, they said that if you look at textbooks, they said Rayleigh and Thomson scattering is the reason for why the sky is blue. And they went back and said, no, this was before the era of quantum mechanics. It has, if you apply quantum mechanical single photon interactions, the behavior. See, Rayleigh and Thomson were using classical electrodynamics, which is kind of the assumption of infinite fluids that are infinitesimally divisible. Whereas quantum, it's, you have little,
Quantized.
right, it's quantized. And they said uh, it fails. So they're actually looking at this question of single photon interactions and then the loss of energy. And they concluded that's why the sky is blue. And then they realized they could apply it then to the interaction of photons through plasma. So I was not the first to say this. That's why I was saying, if I were the first to say this, I'd be really suspicious. But because of work like this, and I've actually thought about contacting Dr. Schneider up in New Jersey. He's driving distance. I said, hey, I'm thinking about getting a PhD in photonics. Can you give me some pointers? I would pursue your research. How much would it cost me to make a laboratory? Because I might be a self-funded PhD. I got a confirmed offer from someone. They said, if you self-fund, you're accepted. so um, that's what I would like to, I'm just saying, this is my personal interest. I would really like to know why the sky is blue. Okay, that's why.
Yeah, I mean, my understanding has always been like Rayleigh scattering, basically, that the nitrogen molecules in the atmosphere scatter the blue frequency of light more. So that's why we end up seeing the blue frequencies and the sky is blue. But if that's not the full explanation, I mean, I'm definitely interested in that paper that you just showed. I mean, that's just my understanding of why the sky is blue, but it's an interesting question, and if it has a deeper answer that is different than the understanding, I'd be curious to know why this paper was not accepted into peer review, but I would still be interested in reading it. And I also, when you were scrolling through the paper, again, I haven't read this paper, so I'm not sure, but I saw a term U or mu, maybe I didn't see clearly, but for like the term was for the expansion of the universe. So in this paper, are they saying that the universe is expanding or not expanding?
Not expanding.
Okay.
That's the alternative. So you saw HO, that's the Hubble constant.
Yes. But I also
And
saw they said U is the term for the expansion of the universe. I saw it just as you were scrolling through, I saw that little line. So I
yes,
just wanted to
so
question.
just here it is. Okay.
Yeah, see, so it says H naught is Hubble's constant, and U is the speed of the expansion of the universe. So I just saw that that was like a term in their equation.
Okay, so it says okay, you asked about the math, so they did it. It is estimated the average density of free electrons in the universe ranges from 10 squared per cubic meter in the intergalactic space to 10 to the fourth per cubic meter in interstellar space. And they gave a reference. A typical galaxy size is 30,000 light years, and typical distance between galaxies is 10 to the 6 light years. Using these distances to calculate the proportional contribution, we can estimate the average free electron density along the path of a light beam through the universe to be Ne. So they define Ne is 10 to the third per cubic meter. Substituting this number in equation 38 yields a value for HO at 68 kilometers per second per megaparsec, remarkably close to the currently accepted range for the values of the Hubble constant of 69.8 plus or minus 1.9 kilometers per second per megaparsec, et cetera, et cetera. And they also said, if not here, I saw it somewhere else. They said this can also, the fact that you identified differing densities in various locations in space, they claim, someone has claimed, I'm not saying necessarily in this paper, that variation is now can be accounted by the differing densities. This is why, to me, this was compelling.
So wait, what did you say about the variation in the density of the plasma? It's accounted for by what?
Okay, so we have this question as what is the Hubble constant? And this is the cosmology in crisis that was brought up in our debate.
Yeah, I mean, I'm really interested in this paper that you're saying it has derived, and what we just read derived the Hubble constant to be close to the observed value using the average density of electron-free plasmas in the universe. So that's interesting, but I do question, Did they ever include a like error bars or like a standard deviation in their average? Like how big of a variation, how
Yeah.
much variation is there in the density of these plasmas?
Okay, so this is you asked why it's not accepted in the peer review.
Yeah.
What sometimes happens is they will put it out on the archive, the Cornell archive. I mean, this is the way it's supposed to work. I'm not saying it always does. Then you can get people interested in your work, and you can get prospective peer reviewers to say, "Hey, that was wrong. You need to fix that." I've actually had where I've thrown stuff up on archives. Editors contact me later and say, "Hey, that was a pretty good paper. Um, I'd be interested in publishing it." So sometimes the reason it's put on archive is you're actually kind of marketing it to editors, because the old fashioned way is you'd have to go write to editors and plead for their mercy to publish in their
Yeah.
journal, and you go through the rejection process. It's nicer if you throw it on an archive, someone picks it up and says, "Hey, this would be a great thing for my journal. Why don't you publish here?" And we've been invited to do that, which has been great. So, um, this would be, I saw this, I said, now you got my curiosity, because it had lots of quantum mechanics.
Yeah. I mean, it's got my curiosity too. I mean, I definitely would like to hear, if there are criticisms or responses to this, I would be interested in reading what they say, but it is very interesting. I have a lot of open questions about it
Yeah.
still, but
Okay. So independent of the big questions. All right. I had to say, honestly, if they can overturn Rayleigh scattering with their
yeah.
theory, that's a more modest goal.
Yeah, well, that would be a cool achievement though, for sure. I mean,
Yeah.
that'd
So,
be progressing science
yeah.
forward.
So this is, well, thank you for entertaining and hearing my side of it. This is
Yeah.
something that we could not achieve in the MDD format where it's all theater.
Yeah, I agree. I like this more conversational, informal format. I think that we should kind of stick to doing the same kind of thing for the more meaty debate, I guess, on Kaz's channel. I'm getting a little bit. I think I need to go.
Okay. Why don't you explain what happened to you? And I think we can continue this.
Yeah,
Well, because I
I've
want
got a
people to know
stomach.
how much you suffered to get on this debate because you were sick.
Yeah, well, I got a stomach bug over the weekend, so I haven't been able to keep a lot of food down. So I kind of need to lay down for a little bit after this. But I still really enjoyed the conversation here, so I'm looking forward to like getting to do like a full untimed thing on Kaz's channel, get it going through all of these points and all that stuff. So very
Okay,
cool
so
stuff.
all right, I'll try to put this somewhere where you can find it. If not, we'll be in touch. I can write to Kaz and say we're on for Sunday. We just have to work out the specific time.
Yeah,
If this format is acceptable to you, or we just kind of say, let's do this, let's talk about this topic, that's fine.
cool. Yep. And then just real quick, did you want to talk about anything outside of like the Big Bang or cosmology, like human evolution or anything, or should we save that
Yes,
for?
yes.
Okay.
We can, and this is sort of a way that we can kind of discuss and say this is of interest. We can postpone to another debate or whatever. These are the sort of conversations that I find valuable. I've learned a lot from you. I didn't know that half the universe is atoms or the
It's a
interstellar
cool
medium.
fact, isn't it?
Yeah, and I did not know that we had them in the temperature range of 89,000 Fahrenheit, which is just like, wow.
Yeah, I mean the temperatures have to be very high for plasmas. That's why I was incredulous at having very low density plasmas because I was thinking that they would cool down. If they were so low in density, then they would cool down and they would like form atoms and they would no longer be plasma. But I'm pretty sure, at least my understanding of it now, is that the particles themselves, like there's no like in order to cool down, you have to radiate that energy away. So if they're not radiating any of that energy away, then they're not going to be cooling down. They're still going to be very high temperature, even though they're low in density. So
See, and that's, I mean, we can talk about that more, but this is what fascinates me is that in the sparse state, it might actually be able to retain that high temperature
yeah,
because it's not a black body. And it's like, then why do black bodies radiate electromagnetic radiation? And it's like, I don't know.
and here's the really interesting thing about the cosmic microwave background is that it is a black body. So I mean, that kind of, to me,
Oh,
kind of,
this is interesting. Our resident particle physics guy, the sun's corona is way hotter than its surface. I didn't know that.
hmm.
See, all right, we have been blessed. Let me just, I'll let you go. I'm just going to close out with some comments and play my end credits. I mean, you're welcome to hang around, but I don't want you to get sick.
I'll just cut the cam.
All right. Well, everybody, glory and honor to our Lord and Savior Jesus Christ. With due respect to people that don't share my faith, I'm grateful Grayson's not offended when I pray. I feel that I need to acknowledge Jesus in everything I do. So this show is dedicated to his honor and his glory. Since I put my faith and trust in him, this is a commitment that I've made, a solemn commitment to serve my Lord and Savior. And I'm going to close in prayer. I'd like to thank Grayson for joining us today. And I'm going to close out with some of my favorite music. And take care and God bless you. Let me just first offer a prayer here. And we lost Grayson. I hope I didn't inadvertently kick him from the studio. I clicked the button and I don't know what happened. So anyway, all right. So I'll close out with Rachmaninoff. So before I do that, let me offer a prayer. Dear Lord, please be with the viewers. We live in an evil age and a fearful time, and we're not promised tomorrow. We lift up the next discussion and debate on Cass's channel, and please help Grayson with his illness. Help us to learn things, Lord. Help us just to make it through the next week. We offer this prayer in Jesus' name. Amen. And so with that, I'm going to play some Rachmaninoff.